The register below can hold its value if green, the variable, equals 0, or shift right if green equals 1, with serial input, write in, and serial output, write out. Draw a similar register that has each flip-flop take as input the exclusive OR as the other two flip-flop outputs if blue equals 0, or can rotate right if blue equals 1. So the circuit that's given here is just given as an example for you to model yours off of. So you're supposed to draw a similar register. So it'll have 3 flip-flops. And since it has a condition to do one thing if a variable has one value and another thing if a variable has another value, then that means that you'll probably want to have a multiplexer. So we'll put a multiplexer up with each flip-flop. And this is always just a good way to start these problems. So you can always just go ahead and do this. You'll have your multiplexers, and those will be your inputs to your flip-flops. These will be D flip-flops. You'll have your clock. So when you're trying to figure out what to do on one of these problems, you can always just kind of get set up this way. This letter that I'm writing is an S. And the variable that we have that's supposed to be telling us what we're doing, the variable name is blue. So I'll just have a wire here, blue. And that will go into the multiplexer and into the S of the multiplexer, and that will tell the multiplexer whether the output is going to be what's going into the 0 of the multiplexer or what's going into the 1 of the multiplexer. And we are told that it's supposed to take as input the exclusive OR of the other two flip-flop outputs. So we know we're going to need an exclusive OR gate, so we'll go ahead and draw those. An exclusive OR gate, and that is going to go, let's see, it says if blue equals 0. So we'll put that into the 0. And it's supposed to be the exclusive OR of the other two flip-flops. So we're going to do the output of the other two flip-flops will be the inputs of that exclusive OR. So I'll put so flip-flop 1, so I'll number these 2, 1, and 0. So 1 and 0 going into that one, and 2 and 0 will go into, let's see, I already have 0 here, so I'll bring it down. 2 and 0 are going into that one, and 1 and 2 will go into this one. So here's 1 and 2, let's see, I have 2 right here. I'll get it from here. Alright, now let's see, rotate right if blue equals 1. So rotate right, so that means 2 goes to 1, 1 goes to 0, 0 goes to 2. So 0 goes to 2, and that's if blue equals 1, so it'll go into the 1 input. So I'll take this output from flip-flop 0, which is right here, and I'll put that into 1. And so 0 goes to 2, 2 goes to 1, so that's right here. And 1 goes to 2, so that's right here.